Applications of nucleophilic substitution reactions. Alkyl halides undergoes a large number of nucleophilic substitution reactions in which halogen atom in the alkyl halide is replaced by other atoms or group of atoms. Hence, nucleophilic substitution reactions of alkyl halides can be used to prepare other type of organic compounds like alcohols, ethers, cyanides, isocyanides, nitro compounds, etc. For example, alkyl halide can be converted into alcohols by treating with aqueous solution of NaOH or KOH, or moist silver oxide can also be used. Moist silver oxide is equivalent to AgOH. Alkyl halides can be converted into ethers by treating with sodium or potassium alkoxide. This reaction is called Williamson's synthesis. Alkyl halides can be converted into cyanides by reacting with a solution of alcoholic KCl. Alkyl halides can be converted into isocyanides or carbylamines by treating with alcoholic silver cyanide. Alkyl halides can be converted into nitro compounds by treating with alcoholic AgNO2. In the case of KCl, it is an ionic compound. It undergoes almost 100% dissociation to form K+ and cyanide ion. Therefore, cyanide ion is a nucleophile in this reaction. In cyanide ion, carbon is having a negative charge and hence carbon is a donor atom of nucleophile. Hence the product is in the case of silver cyanide, it do not undergo dissociation to any appreciable amount. Therefore, nitrogen atom of silver cyanide is a donor atom. Silver cyanide itself is a nucleophile. During the reaction, nitrogen atom is used to make a bond with a carbon atom of alkyl halide. The result is a formation of an isocyanide or a carbylamine. Hence, alkyl halides can be converted into other types of organic compounds. These are some examples. Out of these conversions, conversion into cyanide is most useful. It helps to elongate the carbon chain, that is to increase the number of carbon atoms by 1 unit. For example, methyl chloride can be converted into methyl cyanide by treating with alcoholic KCl. IUPAC name of the reactant is chloromethane. This compound is named as ethane nitrile in IUPAC system. There are 2 carbon atoms in the longest chain. Its common name is methyl cyanide. Cyanide is a reactive functional group. Cyanides can be converted into other types of organic compounds. For example, cyanide on hydrolysis in acid medium gives corresponding carboxylic acid, RCOOH, carboxylic acid. Cyanides on treating with a Grignard reagent R-MgX in a dry ether medium followed by hydrolysis in acid medium gives a ketone, RCOR-. Cyanides on reduction with stannous chloride and concentrated HCl followed by hydrolysis gives an aldehyde. This reaction is called Stephens reduction. Cyanides on a reduction with lithium aluminum hydride or hydrogen and platinum or sodium and alcohol gives RCH2NH2. That is a primary amine having a same number of carbon atom as in a cyanide. Hence, conversion of alkyl halide into alkyl cyanide have a large number of applications. Cyanides can be converted into carboxylic acid, aldehyde, ketone, primary amine, etc. For example, methyl bromide can be converted into ethanoic acid or acetic acid. It involves two steps. Methyl bromide is first converted into methyl cyanide by treating with alcoholic KCl. Methyl cyanide is then subjected to hydrolysis in acid medium gives acetic acid or ethanoic acid. Conversion of alkyl halides into alkyl cyanides can also be used for stepping up in a homologous series. For example, methanol can be converted into ethanol through the steps. Initially, methanol is converted into methyl halide like methyl bromide using bromine in presence of red phosphorus. Then methyl bromide is converted into methyl cyanide by treating with alcoholic ACN. Then methyl cyanide is converted into ethanoic acid by acid hydrolysis. Ethanoic acid on reduction with lithium aluminum hydride gives ethanol. That is, overall change is methanol is converted into ethanol. It is an example for stepping up in a homologous series.